we can again look at another example. An object is projected horizontally with the velocity 10 meters per second. Find the radius of curvature of its trajectory in 3 seconds after the motion has begun. Solution. Let's use a schematic to describe the motion. We have two-dimensional Cartesian coordinates like this. The object is projected horizontally. Let's say it's from here, so it is projected horizontally, so it goes this way, it goes that way, with an initial velocity vector that is horizontal. That initial velocity vector doesn't have a vertical component. It's projected horizontally. That's the implication there. There's the x-axis, the y-axis. What the question is trying to describe now is that this trajectory will have a center somewhere. It goes possibly around, so it has a center somewhere. So assuming the center is like here, so that's the radius of curvature, and that's what we are looking for. Radius of curvature is represented by rho. So what is rho? Well, we will look at it. That rho actually depends, that is radius of curvature in this case depends on the rate at which the vertical displacement of the object changes with respect to the horizontal displacement of the object. Therefore, we can say that this rho is actually equal to 1 plus the y dx square, the y dx square, then raised to power 3 over 2 divided by the square y by the x square. So that is the formula that we will use to calculate the radius of curvature. But how do we get the y by the x and the square y by the x square? So how do we get all this? So that's what we are now out to obtain. To do that, first we use the equation of motion to describe what is the horizontal displacement and what is the vertical displacement. First, we know the equation of motion that says distance is equal to u multiplied by t plus half at squared. Yes. Alright, so the horizontal distance is x. So this s now is now x when we consider the horizontal distance, and u is the initial. This u is the initial velocity and is absolutely along the horizontal, so it's ux, then multiply by time for x motion, plus half. This g will be acceleration due to gravity because it's a projection, so it's acceleration due to gravity. Again, now we are looking at the horizontal motion. Along the horizontal, acceleration due to gravity is zero along the horizontal. So then we multiply this by t square. Invariably, everything here goes to 0. Everything there goes to 0. Therefore, we can say x is equal to ux multiplied by t. In the question, we are given the initial acceleration velocity to be 10 meters per second, and that is our concern is to obtain the radius of curvature after 3 seconds. So t is equal to 3 seconds. So therefore, we can calculate x. Maybe we should say this is equation 1. X is equal to u, which is 10 times 3, and is equal to 30 meters. We do the same thing for the vertical components of the motion, because it's a projectile. Though initially it is projected along the horizontal, over time it has vertical component and horizontal component. So the vertical component, we still use the same formula here. Y is equal to u does not have components initially along the horizontal, so it is 0 multiplied by t, then plus the acceleration due to gravity, half of the acceleration due to gravity, of course, along the horizontal axis, the vertical axis, the acceleration due to gravity will act. So then multiply by t raised by 2. This implies that y is equal to half t gt squared. Yes, we can resolve this. We can resolve this further by saying that this is equal to half g is 9.8 meters per second squared, multiplied by 3 seconds is 3 squared. That is 3 squared. And using our calculator, we can obtain that to be 44.1 meters. Yes. Now, like I said earlier, that the radius of curvature depends on and if you look at the formula here, this is the y, the x, and then the second one is the second derivative of that. So how do we actually write y as a function of x? This is very important to us. It's very important to us. So we have y equals half gt squared. We can substitute this t from where we have x is equal to uxt. From there, we have t equals to x by ux, by u substitute x. So that implies that y is equal to half g, then t now will now be x over u substitute x all squared. So we have connected them. We have made a connection between y and x. So having done that, we can now differentiate. Let's call this one equation maybe 2 now. Yes, 2. So we can now differentiate from here. If we do that, we can have the y, the x is equal to these two will come down here. Yes, this you cancel this out. We have g x 2 minus 1. Yes, it's 1. Then divided by ux squared. And we can differentiate it again to be d square y, the y square equals to now g by u subscript x squared. Yes, from here we find the y dx. From here we find the square y, the x squared. So how do we find this here? This is I think straightforward, except that we know this. So that means we can do a lot here. This is 9.8 times x. We have calculated x earlier. That is 30 meters here. and then divided by u. U is 10 squared. It's 10 squared. So we'll use our calculator to resolve that. So if we resolve it with our calculator, I think we'll get this equals to 2.94 or 2.9 approximately. 2.94 is a ratio of distances or displacement. So no unit, the unit will go off. And again, how do we get this? That is 9.8 divided by u. U is 10, so square. So this is easy to resolve. So this just goes back twice. So we have 0.098. Yes, it's also a ratio that has no unit there. So therefore we can substitute all of this one into the formula that we have, and that will give us this 1 plus, what is this? This is 2.94 square it, yes. Then with this, then divided by square of the square y dx square, that is 0.098. So if we resolve this, invariably what we get is 305.59, something in that neighborhood in meters. So this is now the radius of curvature of the object in this in the described motion. Thank you.